Okay, students, now let us discuss another problem here. Here it is required to hold 4-point charges plus q in equilibrium at the corners of square. Find the point charge that will do this if it is placed at the center of the square. Right. That means here this is the square. Okay. Here we place 4-point charges at A, B, C, D. Plus Q, plus Q, plus Q, plus Q. What is the side of the square here? A. Now what is our aim in this problem? To keep all charges in equilibrium. So definitely there is another charge is placed at the center of the square. This is the diagonal and this is also diagonal. This is the center of the square. That charge must be negative. That charge must be negative to keep all charges in equilibrium. If this charge is positive, then these all charges are not kept in equilibrium. Please check yourself. Right. Let us solve this problem. Here this is A, and this side is nothing but how much? Root 2A. And the distance between this charge A to center of the square is equal to A by root 2. This is also A by root 2. A by root 2 from mathematical calculations. Right. This is the Pythagoras theorem. Side square, this is A. This is also A. Side square plus side square. Hypotenuse square is equal to side square plus side square. So we get root 2A here. Okay. Now let us calculate the equilibrium of charge Q present at A. Now the force acting on charge A due to discharge B. That means that is a repulsion force. That force is acting along this direction. Force acting on A due to B. The force acting on A due to D, that is also repulsion force, that is acting along this direction. FAD. Okay? FAD. The force acting on A due to discharge, that means due to C, that is FAC. That is repulsion force, that is along this direction. FAC. Right. Here the force acting on A due to negative charge along this direction. FAO. Okay. Right. Now we calculate FAB. FAB is equal to, do you know Coulomb's law? Force acting on A due to B, 1 by 4 pi epsilon naught Q1 Q2 Q into Q divided by A square. Okay. Next, F force acting on A due to D, 1 by 4 pi epsilon naught Q into Q divided by A square. See, these two forces are equal. This is equation 1 and this is equation 2. That means FAB is equal to FAD, that is equal, let us assume F. That means these two forces are equal in magnitude. They are acting perpendicular directions. So the resultant force is along this direction. The resultant force bisects these two forces. So that is nothing but root 2F. That is nothing but what? Root 2F. So if the sum of these two forces are balanced by this force, in opposite direction, then this charge A, this charge kept at A is in equilibrium. That is the condition. So, what is here FAC? What is here FAC? FAC is equal to 1 by 4 pi epsilon naught Q into Q divided by, this is root 2a whole square, right. For equilibrium of A, what is the condition? FAB, okay, FAB, and the resultant of FAB and FAD, the resultant of FAB and FAD, that is nothing but root 2f plus, that is root 2f along this direction, and FAC, force acting on A 2 to C. These two forces are balanced by this force, that means FAO. Right, now root 2 into, what is the value of F here? FAB and FAD both are same. FAB and FAD both are same. These are assumed as what? F. So 1 by 4 pi epsilon naught Q square divided by A square plus FAC, what here? 1 by 4 pi epsilon naught Q square divided by AC 2A square. Okay, right. FAO 1 by 4 pi epsilon naught small q into capital Q by A by root 2 whole square, A square here 2, right. What are the common here? Here in this these two sums common here, 1 by 4 pi epsilon naught Q square by A square common, Q square by A square common. So, we get root 2 plus 1 by 2 is equal to, here 1 by 4 pi epsilon naught Q into 2 divided by A square, So, what are the cancel term here? 1 by 4 pi epsilon naught cancel, A square gets cancelled, this is Q cancelling Q times. Now, we get Q into root 2 plus 1 by 2 is equal to how much? 2Q. Is equal to how much? 2Q. So, Q is equal to how much? Q into root 2 plus 1 by 2 divided by 2. This is the value of Q required at the center of the square to hold all 4 charges in equilibrium. This must be, Q should be assume Q should be positive or negative? Q should be negative. Then only all 4 charges are keep in equilibrium. If it is positive, then these 4 charges are not in equilibrium.